Hi everybody, and welcome to this video about advanced DnSpy tricks in .NET Reversing Part 2. I'll be covering debugging PowerShell process when debugging PowerShell scripts. So we will be debugging PowerShell script in the Visual Studio Code, and we will be debugging the PowerShell process itself in DnSpy. So whenever something happens on the .NET layer, we will catch it in the DnSpy debugger, and whatever happens on the PowerShell script layer, we will catch it in the Visual Studio. We will be transferring the control from the DnSpy to Visual Studio Code, and from Visual Studio Code to back to DnSpy. So it could be very, very tricky and quite neat. So next thing will be DnSpy multi-process debugging. So this is some kind of feature most people are not aware of, but this could be very, very handy. I will show you how you can do it. Next thing, we will be dealing with code optimization during .NET debugging. Code optimization is something what I will explain also later, but whenever you create .NET assembly, like in C# and compile it to exe file, it's like code is in like intermediate language, MSIL, so IL code. And this code is like whenever you execute this assembly, this code, something happens with this code, and this something is called like a just-in-time compilation. So the intermediate language, the IL code, will be compiled to the assembly just in time. And during this compilation, default option is that optimization happens. What is optimization? That some code, some function, original function could be inlined, some local variables could be removed from memory, so the memory structure after the compilation, after the optimization, could be different to the original one in the assembly. So where you can encounter this? Usually when you are attaching to some process in the DnSpy debugger, this process is already optimized. So you will encounter things like that you can't see some local variables, you can't put the breakpoints on some methods, because the location, the addresses of these stuffs changed in the memory because of the optimization. And I will show you how you can deal with it. The last thing will be watch window versus locals window. How to invoke expression in watch window, how you can put variables you are watching in the watch window to locals, and how you can put the local variable to the watch window and benefit from both of them. It's very, very tricky, very, very good, because in watch window you can actually see the fields, which works like global variable in .NET. So I will show you. Let's start. For this exercise, I prepared. There was some kind of async infection chain you will encounter very often, but one of the stage was a PowerShell script. And this PowerShell script is some kind of decoder and loader. It contains two assembly files. One is injector, which is performing PE hollowing, and the second one, which is like injected to some target process, is async payload. So let's start with the PowerShell script. And here it is. Yeah. So view word wrap. And first of all, I want to debug, because we will be launching the script and it has to be like execute in PowerShell process. I want to debug the PowerShell process in DnSpy, and I know that these two assemblies are 32-bit architectures, so I would like to debug all of this in DnSpy 32-bit. So for that, I need to change the session, like to use not using PowerShell, but I want to use Windows PowerShell and 32-bit. Nice. So this should be okay now. Yep. And yeah, we can start. Here are some decoding functions. We are not interested in them. But what you can see here, like sleeping, something, and here you can see very often 45A, which is some basically hexadecimal encoded MZ header, but there is something like there the exe files are encoded. We are not interested in them much, but you can see that there are two of them. And if you check this more carefully, you can see here is some path. But what you can see here, the system reflection assembly. So this goes here, and it will be invoking method load. So one of the assembly will be loaded, and from the one will be invoked one function. We don't know the name of the function yet because it's encoded somewhere here, but this one assembly is actually injector, so it will be performing the PE hollowing to some specified target, and the payload which will be injected is the async, and this async is the second we can see it here, this one assembly encoded here. Oh, surf here. So nice. We can put some breakpoints, for example, on the module loading, and here on the invocation of the injector. Yeah, on some method. Now we can start the debugger. So press 5, and we will hit the breakpoint on the loading of the already decoded one. We can we can see the things like these two assemblies are already decoded, yeah, in memory, like in PowerShell. If you want to dump them, you can do it very easily here in PowerShell. You can do something like set content path will be payload 1, value will be some variable. Yeah, you can see here is the same. It works like intermediate window. You have the same context as in the debugger, so the variables and everything is known here. So you can dump the first one, which should be this, and this should be the injector. Yeah, and we can do the same for the second one, which should be the async, and it should be this variable, the payload rf. Yeah, nice. If we check the dumped results, you can see it here. Oh, yeah, I know what happened because I didn't specify the encoding for outputting, and I want to specify it as a byte, and the same for payload 2. Nice. And that's correct. Now if we check that, both of them are MZIT, like exe files, assembly is nicely decoded. Yep. And if you check them, both of them are, I think, obfuscated. Yep, confuser. And here the async is obfuscated with some custom obfuscator, but it doesn't matter. I want to show you also that you can see the original file name, for example, like here. Okay, it should be DLL. This one is the injector, and you can see here if you go to the tables and assembly, the original, like the assembly name is Git. So this one is the injector. It will be loaded to the PowerShell process space like via reflection, and the second one will be which will be injected to some target, will be the async. Now we don't need them, so let's continue what we want to do. So let's start the DnSpy, and we can here I will check that we have not enabled module breakpoints yet. A debug, attach to process, and here the PowerShell. We attached and it's running. Yeah, it's running. You can interact with it. Yeah, nothing special. Yeah, you can do whatever you want. So now put a breakpoint on the module loading, So the Git will be loaded. You can see here that you can see here or already loaded modules. Yeah, but new one will be loaded because you can see it. You can see it here that the injector will be loaded. So we put a module breakpoint like on the loading, and we can continue. And we should hit the breakpoint here. You can see that the control is transferred to DnSpy, and we can interact here. Yeah, we can do anything here. So yeah, you can see module loading and the Git, the name of the module. So what you can actually do, you can go to modules, and you should see them here. Here is the Git, and you can see it's from memory. Yeah, there is no path here. So let's open it, check it, and here you can see some like a typical API function used for PE hollowing. Yeah, create process in suspended mode and resume thread, set thread context, get thread context, other things. But we don't know what function will be invoked from the like entry point from this DLL. So let's come back to the. We can delete the breakpoint and disable it or other things, but we want to transfer the control back to the Visual Studio Code to continue the debugging. So to get idea what function will be invoked in the injector. So let's continue here, and you can see that the Visual Studio Code has the control now. Yeah, and we hit another breakpoint. What we can see, what function will be invoked here somewhere. Get method execute. Yeah, so the execute function will be invoked, as you can see it here. So if you check it here, go to execute and put a breakpoints here, somewhere here. Okay, and now you can continue, and you will basically, you can see here is some kind of argument like this one should be the payload, and this one should be some path. Yeah, that's very, very tricky and neat. You can see here the path. This path will be used as a new created process where the payload will be like targeted and injected to. So let's continue, and we will hit the breakpoint here. You can see it, and we are here. So quite nice. You can see that you are debugging one process. You can see the call stack and whatever. You can see also the locals. Yeah, because for in-memory module in-memory loaded modules, the optimization is like turn off. You can see turn off. Nice. So let's investigate this one a little bit, because we want to do. Now I basically introduced the debugging of the PowerShell script and debugging the PowerShell itself in the DnSpy and like this was quite tricky. But what I wanted to do is we need to find, as its injector, you can see it here immediately. So we need to find some interesting function. You can see it like here. That interesting could be, for example, resume thread or a create process. Yeah, for example, create process. Whenever you want to, you can see that create process is interesting, but you can use like function like analyze here. Yeah, in DnSpy, the feature one. But analyze and check use by and iterate, find all references. But if you want to just every time pressing analyze, you can actually press tabulator, and it will iterate the location where the create process A is used. So tabulator, and you can see here the location, and you can see here some definition. You can see here there is some initialization, as you can see, loading API and create process like delegation, and here it is basically used. So put a breakpoint here, and the second one, which could be quite interesting, should be the resume thread. And again, press tabulator to iterate where it is used. And here you can see that it's initializing like Yep, and here is like using the resume thread, which should be the last function before the p hollowing is finished. So let's continue. And we hit the first breakpoint on the create process A. You can check the path. The path points to some legitimate assembly in Windows operating system from .NET Framework, and you can see some attributes here. If you don't remember, just try to Google. You can see here the definition: 1, 2, 3, 4, 5, 6. The sixth argument should be creation flags. Yeah, so 1, 2, 3, 4, 5, 6. This one is creation flags, so something like 08, 00, 0004. What does it mean? I already know that it's like creation without no, like creation no window and create process suspended. But if you don't know, you can always Google these things, yeah, because we can't remember all possible arguments and values and enums and other things. So let's check here the creation flags, creation flags, creation flags, here creation flags. And if you check the values 08, 08, 0000, create no window, and the 4 is here, create suspended. So as I told you, if you check it, like step over it, the new process should be created. You can check it in Process Hacker or Process Explorer. New process ASP.NET compiler is created and it's in suspended mode. The gray color, if you check here the options and highlighting, the gray color should be suspended process and threads. So it's in suspended state. And if you check the memory, like here, there is only like one. Yeah, you will see later how this changes. So okay, we can continue. Continue, and we hit the second breakpoint on the resume thread. So now the target, this process, the ASP.NET compiler, should be already hollowed. Yeah, so let's check it in Process Hacker again, and what you can see here, there is like normal module, but on typical base address there is injected the async read. You can see protection, all protections are set as a read write execute. You can see here, yep, it's executable. Nice. What we can do, we can actually now try to do multi-process debugging. Um, this part, multi-process debugging. I will show you. And so go to processes, and whenever you will step over this, the thread will be resumed and the process is running. So if you do this like F10, it's already running, and you can attach to it like attach to process and here and break. Yes, now we have like this two processes. We are now performing multi-process debugging. It's very, very tricky because in this process, in the PowerShell, we are somewhere here. And in the second one process, if you just switch to this, you can actually see like modules, and you can see the modules only in the specified process. So for example, here, and here it is. So if you want to just debug only this one, just open module frame memory and go to main, and you can see it here. So nice. We can put some breakpoints, but what I wanted to show you, we will put some breakpoints here, I don't know where. What you can see here, that there are locations we can set a breakpoint on. Yeah, for example, like this one. Why? Let's continue. Wait, I will put some more breakpoints. I will explain. Come on. Yeah, we hit the breakpoint here. So if you check the locals, you can see that you can read the I variable, which is this one, the local variable for like looping. Yeah, so this is strange. Another thing is basically you can set a breakpoint on some location. Yeah, like this. If you step to some function like this, you can see again, yeah, and here is the tip that this value of local variables arguments because it's not available at the instruction pointer, possibly because it has been optimized way away. So yes, this is because of the optimization, and we are now stepping to the third part, like dealing with code optimization during debugging, because we were actually attaching the process and it was already optimized. So what I mean, you can see that the local variables are out, yeah, so you can also see that you can set breakpoint on some location, which and on many location. This is very, very bad. Yeah, so how to deal with this? Remember these things, remember them, because I will show you later on, after we defeat the optimization. But you can see when you encounter, like, you can see local variables, you can put the breakpoints where you want, because this function in memory could be actually inlined, the location could be changed. Yeah, so on the pointer in the address there is no function as it was in the original assembly. The local variables could be removed, or could be the address could be changed or something like that because of the optimization. So now we can actually go to processes and stop this, terminate process, and we can actually again detach from this. Yes. So close all, and once again, but what I want to show you, okay, we will do this once again. View, word wrap. Now, how we can actually deal with the code optimization? There is also a hint on the DnSpy wiki page that whenever you wanna turn off the optimization for some process for the module, you have to create an init file with some settings with the same name or as the module, and it will basically is able to turn off the optimization. Yeah, so for example, if you go to the DnSpy GitHub DnSpy X GitHub, and you will go to the wiki page here, making an image easier to debug when attaching to a random .NET process is most likely already optimized. What I showed you, and you can see that there is like things debugger can read all locals or evaluate expressions or call methods and other things. So if you must attach the process running .NET, Microsoft recommends creating an ini file. Yeah, if your DL is something DLL, then create something ini file in the same folder with the following contents. Nice. This is for .NET Framework. For .NET and .NET Core, there is like another tips how you can disable the JIT optimization. Yeah, so okay. Now we have here the example ini file. You can check here that here is the settings, .NET Framework debugging, generate tracking info. This one could be avoided because from .NET like 2, .NET Framework 2, there is always like generating tracking info. So this is not like mandatory, but allow optimize has to be specified because the 0 here it will disable the optimization of the specified module name. So okay, as we know the name, I don't remember, but I think it was like somewhere, if we check that once again, 5, come on, and the name was somewhere path replace. Okay, we can actually do the same, I think, here. Path replace here, like this. And here is the path. Copy, and let's find it. Because we need to create the init file in the same directory with the same module name, but the extension will be ini, open path. Let's create the init file here. Yes, this one, and we can put it to the location right next to the module. It doesn't matter that basically the that the module will be like in hollowed, yeah, with the injected payload, because it's like settings for the process starting, like for the process environment, that no optimization for this module. Yeah, so that's cool. Now we can actually do the same as we did before. Let's debug, start debugging, attach to process, PowerShell, yes, model breakpoints, here, come on, continue, we hit the breakpoint here, go to modules, check the last module, which should be somewhere here, open it, you can see it here, locals, execute function, put the breakpoint here, we can disable the module breakpoints. Let's continue, switch back to the here and continue. Now we are here, and again check the locals. Okay, everything, we already saw this things, but what you can actually do, you can now go again to the resume thread. Okay, come on, resume thread, somewhere here, and from to the location where it is used, it's used here, and continue. And now go to the processes, we can actually step over it and attach to this. Step over it, attach, and here attach, and break. Nice. Now we don't need this one process, so we can actually continue this one. Yep. And we can detach. Yep. But we can debug both of them, switching the contexts. Yeah, you can actually go to modules view and select only for for some processes. I think you can do the same for some other things, but you can see the threads. Yeah, you can see the threads like okay, there is no super processes, like okay, but I don't want to see this one, so detach one, and you can see the execution is here. Yeah, the controlling, we don't need this one anymore, so I think we can close it now. Oh, stop. Let's go to this one. So file, close all. And what I want to show you, if you go to the modules, you can see that the optimized is no. And before it was yes. And this is because of the init file we created. So no optimization for this module, which is super, because if you check that, open module from memory, main, and put some breakpoints here, like, I don't know, somewhere here, because we didn't catch it in quite a nice way. So let's continue. We hit the breakpoint and check the locals. You can see the I variable. Yeah, the content of this we didn't see before. What is another more interesting thing, you can put the breakpoint whenever you want. Yeah, no error like before. I will show you. Like when you press F10, F11, like step in, you can see this function. And if you remember, we were here before, and you can see things like this, like the local variables already. Yeah, you couldn't like set breakpoints. Now you can set the breakpoints on all locations because the optimization, the code optimization was disabled. Yeah, so that's very tricky. You can step, continue, and you can see everything. So this was about the code optimization, how you can deal with it when attaching to some process and other things. And the last thing was we can actually stop the debugging, like I think here, and terminate. And we can save the module, because what I want to show you, save code, save module, and put it to some different location. I want to show you now the difference between locals and watch window. So, okay, file, close all, here, ASP.NET, ship, main, here, and start. Okay. Now we hit the breakpoint, and what I want to show you, difference between locals and watch window. That's very tricky, because what you can do with that, it's extremely useful. So we put here the another breakpoint, continue, come on, and here it is. So for example, we can step in, and you can see that in the local windows, locals, you can see here the fields. Yeah, you can see the return values, but you can't see here the fields, for example, like here. So what you can actually do to see them, yeah, what you can do, you can use the watch window, and in watch window you can evaluate expressions, so it is able to print you or to get you the values of the fields, so like this. Yeah, so we can find some interesting thing here, for example, yes, and you can see them in uh, in every class. Yeah, there will be used. Yeah, so it's very useful. Okay, sorry, I screwed that. It should be like this, because this one is only type. But I want to see especially the C2D domain names and the ports from the config file. This is basically some configuration, and I think it's somewhere like one of these, maybe. Okay, maybe I will just, the faster will be going to somewhere like before, here, and here it's used, and here it is parsed. So basically what we can do, I can actually show you here. Here it is, and here should be like the ports, I think. Nice. So we are somewhere like here, but I don't wanna, I want to go somewhere here and continue. We hit the another breakpoint, and we can actually step here, like a step here, set, next statement, and step in. Nice. So you can see that now you can actually see the values which are used here, yeah. And if you don't, you can set, like, grab this one and copy and put it here and other things. But this is not good, because you can see in the locals, you can see locals, and in watch window you can see some fields and other things. What could be very handy, I will show you. So let's put a breakpoint somewhere here, continue, and if you check the locals, you can see that text, what the text local variable contains, yeah, some localhost. Okay, but actually, Here you can see some expression. You can invoke this expression in the watch window. This is extremely useful. Bam, and you know what will be the result before the calling. Yeah, so that's extremely useful. You can actually delete the watch. Okay, but what I want to show you, you can see in the locals, you can see the fields, and in the field in a watch you can see the locals. But what you can actually do, you can mark all of them and make an object ID. This will like create object ID for all of them, and what you can see the object IDs in the locals. Nice. Now you have in the locals window all local variables and also all what you have in the watch. That's pretty cool. But if you can see, we lost the naming of the fields. We have it's like object ID. Yeah, so that's not good. Yeah, so we can what you can actually do, and it's better, you can again delete the object ID. You can mark all of this and add it to watch. And now in the watch view, you can see the names of the fields, the value of the fields, and you can see all the locals. So for example, if the num is changed, you can see it here. Yep, you can see it here. So whatever you have in the watch window, you can port it to the locals. Whatever you have in the locals, you can put it to the watch. But the watch window that doesn't have to make like object IDs. So when you create an object ID for what you have in the watch window and it will be put to the locals, you will see the object ID and not the original name of the field. So that's bad. But when you are using the watch window, this is pretty cool because now in this function, with everything what we want, we can see the values of some fields. Yeah, you can see that BDZK is here, and it contains the C2 domain names. Yeah, so that's pretty cool. Yeah, and you can do whatever you want. And this was actually about the locals versus watches, and I hope you like it and you enjoyed it. And I think that's all. So we can stop it. I will just make sure it's not running. Yep. So what we covered all what I wanted to cover. We covered debugging PowerShell processes when debugging PowerShell scripts, DnSpy multiprocess debugging, dealing with code optimization during .NET debugging, which is very handy. And remember, whenever you are attaching, you don't have to debug just like malware only. You want to, for example, troubleshoot something. You are like exploit finder or pen tester or something like that. You want to reverse IIS server and things like this, which are written in .NET. Whenever you are attaching to some already running process, it's very likely already optimized, and you will probably have to deal with that. You can see things like locals, you can put the breakpoints where you want and other things. So a good thing to recommend is create any file for the desired modules and rerun the process, rerun the IIS or whatever, and you can attach the debugger later on, the DnSpy, and you will see the locals. You can put breakpoint where you want because the optimization will be disabled. Yeah, so that's it. Watch versus local windows. In DnSpy, I think I actually introduce it in quite a deep way. Watch window has far more benefits than the locals. Whatever you have in the locals, you can have in watch window. Yeah, but in the watch window, you can like invoke expressions. You can see the fields which are initiated in different classes and whatever. So I hope you enjoy this. Thank you for watching and see you next time.